Okay, these are your notes that are entitled Geometry Notes 1.4. They don't match up again with your book, but the reason we do this is just that your book doesn't, they assume you remember all this stuff, and a lot of people don't, okay? So the thing we see first is two angles with a common vertex. Okay, so let's say I've got this angle, and I'll draw another angle. I'm not going to worry about putting the arrows on the end because I know you guys know they're there, okay? I'll do it, I guess. All right, so you got these two angles. There's the blue angle and then the red angle, and the red's kind of covering up the blue. But you see that they share a common vertex. So you want to put vertex in a blank, and because this is the vertex they share, and they share a common side. Side goes in that other blank there that's littler. That red and that blue are on top of each other, aren't they? That's a side that they share. But do not share any interior points. Those are adjacent angles. Interior, I-N-T-E-R-I-O-R. Hard to get it to show up sometimes, okay? So when they're connected to each other like that, they're called adjacent angles. A linear pair are two adjacent angles whose non-common sides are opposite rays, okay? Remember how a while ago I said if we had an opposite ray like this, we had, what if I had two angles and they look like this? One of them is this small angle here, and the other one is this bigger angle here, okay? Well, when they're out, the side, they share a common side, right? The common side is right here. These other ends of them aren't common, are they? They're actually opposite rays. They form a line. Let me outline the line. This is used tons in your proofs, okay? So the measure of a linear pair of angles is 180 degrees. Linear pairs, we say they're supplementary. They add up to 180 degrees, but not all supplementary angles are linear pairs. If they touch like this, they're supplementary. That word's right down here. Supplementary means two angles add up to 180 degrees. If they form a line like this, they're called a linear pair. But supplementary means they add up to 180 degrees. I'll come back to complementary in a minute. But here's an example of two angles that are supplementary. Let's say that's 30 degrees. And then let's say over here I have 150 degrees. They're not joined together. They're not adjacent, are they? Those two angles add up to 180 degrees if I add them together. So they're supplementary to one another, but they're not a linear pair, the ones that I drew here on the bottom, because they're not sharing any sides, okay? So sometimes definitions can get a little tricky. You got to be careful about that. Now going back up to complementary angles have a sum of 90 degrees. They do not have to be adjacent. Sometimes we have adjacent complementary angles. Let's say you got a right angle here, because a right angle's 90 degrees, and let's say that you come in and you've got a little, maybe 30 degrees here, maybe you got 60 degrees here, and they add up to 90 degrees. Those are adjacent angles that are complementary, but they don't have to be adjacent to be complementary. I could have a 30 degree angle and a 60 degree angle, and those are complementary, but they're not adjacent. Okay, so anyway, that's all there. Oh no, that's not all there is. I'll have to move the sheet down. The last one on this 1.4 page is vertical angles. Two non-adjacent angles. Let me see. I always have trouble. You hear all that background noise? I'm getting a new roof today because of all the storms. Two non-adjacent angles of two intersecting lines. Let's say I have this line here, and I have this line here. The two angles across from each other are called vertical angles. This one and this one are vertical angles, the two ones that I marked with red. And let me pick a different color, maybe purple. This one and this one are vertical angles, and vertical angles are equal. So I actually marked them with the same number of marks. The two red angles are equal when they're directly across from each other like that. When they're vertical angles, are always equal. So the two red ones are equal to each other, and then the two purple ones that I drew are equal to each other. Okay, these are the 1.5 notes. I'm going to try to go through these quickly. There's just some vocabulary you need to remember. Perimeter is the sum of the side lengths. So if I have, if I have a figure, it doesn't have to be anything in particular. Let's say it's a triangle. And I want the perimeter. I just add up all the three sides together and see what it is. And that's the perimeter. So it's like a little ant crawling around the rim, is how I used to remind my daughter when she forgot it. Now if I want the area of that, the perimeter would just be the side 1 plus side 2 plus side 3. Now the area, remember this is a triangle, so the area is something different, isn't it? It's how much space is inside that figure. It's the number of square units in the figure is the area. So we have some formulas for a rectangle. There's two sides that are equal here that we need to add together. So they say if they call that the length, that's 2L. And let's say you call these two sides W. There's two of them. So you could say L plus W plus W, or you could combine like terms and say 2L plus 2W is the perimeter. The area would just be length times width, or base times height. So those formulas are there for you. We're going to use them throughout the year, and we're going to just assume that you remember them from lower grades. Now for a square, all the sides are the same. So I could say side plus side plus side plus side, or I could combine like terms and say the perimeter, if I add up all these four equal sides, would just be 4 times one side, 4S, if one side is S. If one side is S, all the sides are S, right? So if I did base times height, I would get side times side, or I could say side squared. So that's why that says that on your sheet. The triangle we did above, you add all three sides together. They're assuming like maybe you call these A, B, and C, I guess. And if you remember that the area of a triangle is 1/2 base times height. So you'll be using those. And then you'll be talking about circles. If you remember, the diameter of a circle is a line that passes all the way through the circle, and it goes through the center. And it's equal to 2 radii. Remember, half the way through the circle is a radius, and we use that in a lot of formulas. It's a segment with one end point on the center and one on the circle somewhere. Okay, so diameter is equal to 2 times the radius. That's an equal sign in between those, so you can't tell it. Okay, and then we have perimeter and area formulas for circle, but we don't call it perimeter in a circle. We call it circumference, going around the outside of the figure. And for circumference, we actually have, you can use whatever formula you want. You're going to see that I have a preference, and so I'm going to use this one just because I like it. You can call it pi times diameter, but the diameter is 2 times the radius, so if you say the diameter is 2 times the radius, we usually write that as 2 pi r, and the reason I like that is because most of the time we're going to plug r into a formula, radius, and so I just like to use the one that has r in it instead of remembering 2 pi, r and pi d. I just use 2 pi r. You're welcome to use pi times the diameter, but you're going to have to be able to remember that a diameter is 2 radii. And the area of the circle is pi r squared, so we have to multiply the radius by itself and then multiply it by pi. In geometry, I know that you were probably used to in lower grades using 3.14 for pi, but a lot of times, let's say I had a radius of 5. If I were trying to find the area, that would be pi times 5 squared. What we do a lot of times is just write this, instead of using 3.14, we just say 25 pi. It's actually easier to use it, and it's exact. Now, if you were really using this in real life, you would want to use the decimal, but most of the time we just don't have to get the calculator out and plug 3.14 or HAL 3.1416 or whatever it is we want to use in. So we just do this instead. It makes the computations easier. It actually makes some reducing things easier too if we start comparing figures. So you're going to leave your answers in terms of pi this year, which means you're just going to go ahead and square the 5 and then write the pi with it. Treat pi kind of like you would an x, except we know it's not really an x. It's a number that has a value.